Today, I'm going to show you an experiment on MOSFET as a switch using Proteus software. This is the circuit diagram. At the end of the video, I'll show you how to construct this circuit in a Proteus. So the circuit which I have constructed already, I have taken in this Word file. And here, the potentiometer is used in order to vary the power supply voltage. This potentiometer adjusts the voltage applied to the MOSFET gate. This voltage is applied to the MOSFET gate, and the potentiometer adjusts the voltage applied to the MOSFET gate when the switch is closed. Here I have taken SPST switch. When switch is closed, the voltage will be applied to the gate of the MOSFET. This SPST switch, single throw, single pole, single throw switch, it acts as a control to connect or disconnect. You can connect by closing it, or you can disconnect by opening it. Connect or disconnect this potentiometer from the MOSFET gate. So that is the role of SPST switch. I have connected one 10 kilo ohm resistor between gate and a source. This is gate, source, and a drain. So between gate and source, the 10 kilo ohm resistor, it acts as a pull-down resistor. So it ensures the gate is pulled to zero when the switch is open. When you open the switch, gate should not be in an open condition. It should be connected somewhere. The gate is connected to ground. So when the switch is open, and it prevents unintended MOSFET activation. So for that purpose, 10 kilo ohm resistor is used. And there is one 330 ohm resistor. Look here at the drain side. So this 330 ohm resistor, it is in series with LED. So it will limit the current through the LED. Therefore, it is called as current limiting resistor. So which will prevent the LED with this current limiting resistor. It limits the current through the LED to prevent from the damage. So that is about the 330 ohm resistor. Then the main component in this circuit is MOSFET. The MOSFET, it acts as a switch to control the LED based on the gate voltage. When you apply the gate voltage, so when MOSFET becomes on, LED becomes on. When you remove the gate voltage, MOSFET becomes off and the LED becomes off. So this is about the role of each component. Okay. Next, the potentiometer wiper. This is wiper. It is disconnected from the MOSFET gate due to the open switch. Initially, we will open the switch. So I'll show you now. So this is the circuit for a circuit in the Proteus. I have already constructed using Proteus. Now I'll run the simulation. So I run the simulation. Now switch is in closed condition. Since switch is in closed condition, LED is on. Now I'll open the switch. See, the LED is off. Connected from the MOSFET gate due to the open of the switch. This 10 kilo ohm resistor, it is a pull-down resistor. It ensures that the gate of the MOSFET is at a ground level. That is, ground potential is 0 volts. The MOSFET remains off. Off means cut-off region. It remains in off state as the gate source voltage is 0 because the switch is open now. Now I'll close the switch. So when I close the switch, see, when I close the switch, this will connect the potentiometer wiper to the MOSFET gate. So the voltage at the wiper set by this potentiometer is applied to the gate. Okay. So if this gate voltage exceeds the MOSFET threshold voltage, then only the MOSFET enters into the saturation region. I'll show you. Now the switch is closed. I'll reduce the potentiometer voltage. See, you can check here. It is 4.21. I'll keep on reduce the voltage. 3.7, 3.64, 3.57. So the LED is turned off. So it means the voltage exceeds this threshold voltage. Then the MOSFET enters into the saturation region. I'll click on the next step. 3.64, the MOSFET is turned on. 3.57, MOSFET is switched off. So the threshold voltage required to turn on the MOSFET is 3.64 volts here. When the MOSFET is on, it acts like a closed switch. See, the voltage between drain and source becomes 0. When it is in off condition, check the voltage. The voltage between drain and source is 2.17. So here, when the MOSFET is in on state, when it becomes on, it acts as a closed switch and it connects the drain to the ground. That's why the voltage is becoming 0. So when it is open, then the drain is not connected to the source. I'll get the voltage between drain and source is 2.17 volts. So here, when it is closed, the current path is established because drain is connected to the source. The current starts flowing from 5 volts. I'll show you with the pen. Okay, so the current starts flowing from 5 volts, 330 ohm, LED anode, LED cathode, MOSFET drain, MOSFET source, okay, MOSFET source, ground, and back to power supply. The closed path is established. So because of this, the current flows and LED turns on. Okay, so when the switch is opened again, so I'll close this. When the switch is opened, see, when the switch is opened again, the connection between potentiometer wiper and the MOSFET gate is disconnected and it is broken. The 10 kilo ohm resistor, it is quickly pulls the gate back to the zero potential. So the MOSFET turns off. Therefore, the LED turns off. So the MOSFET no longer conducts and it breaks the path. So in this way, the MOSFET acts as a closed switch and a open switch. So you can use the MOSFET as a switch in this experiment. Now I'll show you how to construct this experiment. Now I'll close this project and I'll open the new project. Click on new project. Give the name of the project as MOSFET as a switch. Okay. Click on next, 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 finish. So we will get workspace here. So click on component mode, click on pick devices. Here I want MOSFET because I have done video on real mode also, experiment using IRFZ44N MOSFET. I'll choose that only. IRFZ44N MOSFET. So this MOSFET only I'll take because the same thing I have used in a hardware experiment. I'll place here. Okay. Next, I want DC source. Click on V source. V source, DC voltage source. Click OK and place here. So I'll adjust this to 5 volts by right clicking in edit properties, 5 volts. Click OK. Then I need one potentiometer. So select port HZ. Pottage is active. Click OK and place here. Connect one end of voltage source to Pottage, other end of source to Pottage. Adjust the Pottage resistance to 10 kilo ohm. Click OK and connect the wiper to one switch. So select one switch, SPST switch. SPST switch. Click OK. Place here. Okay, connect one end of the wiper to the switch. Other end of switch to the gate of the MOSFET. Okay. Next, in order to measure the voltage, I need one DC voltmeter. Connect between these 2 points. Drag this. And connect the ground to another end of DC source. Okay. Next, I need 10 kilo ohm resistor. Select resistor. RESU type. So you'll get resistor. Generic symbol resistor. And place here. Rotate in anti-clockwise and connect this to gate and other end to the ground. Okay. And adjust this to 10 kilo ohm. It is already 10 kilo ohm. Now connect the source of the MOSFET to the ground. Okay. Next, select one ground here. Connect this to ground. Okay. Next, I need one voltmeter. And before this, I need one LED. Select LED. I want LED BB only because this will work correctly. Select LED BB and connect here. And connect to drain. And I need one resistor again. I'll place here resistor. Adjust this resistor to 330 ohm. It is 10 kilo ohm. Adjust this to 330 ohm. Okay. Click OK. Connect the anode to the resistor. Okay. Next, I need another DC source on the output circuit. Adjust this to 5 volts. You can give 10 volts also. For MOSFET, I am considering 5 volts. And connect one end of the resistor to source, other end to the ground. Okay. So now, if you want 1 voltmeter, you can connect one more voltmeter across the LED in order to measure the voltage. And you can connect one more DC voltmeter between drain and source in order to know that MOSFET is on or not. If it is on, we will get 0 voltage between drain and a source. If it is off, we will get nearly 2.5 voltage between the drain and a source because we have applied 5 volts supply here. Okay. Now you turn on the simulation. When the voltage reaches a certain value or the threshold value, then only the MOSFET will be turned on. This is about the construction. So how it executes, that I have already shown. Okay, so in this way, the MOSFET can be used as a switch.